Imagine a mission so fraught with peril that its survival depended not just on cutting-edge technology, but on sheer human ingenuity and determination. Welcome to the extraordinary story of Apollo 13. I'm Dr. Mira Alden, and today we're delving into this iconic mission that took an unplanned turn and captured the world's attention like never before. Launched into the void of space, Apollo 13 was the seventh crewed mission in the Apollo space program, a monumental testament to human curiosity and ambition. The stakes were incredibly high. Not long after launch, what was meant to be NASA's third lunar landing mission soon spiraled into a high-stakes battle for survival. An unexpected crisis would see the world's sharpest minds pushed to their absolute limits. But this isn't just a tale of near tragedy. Far beyond the numbers and technical data lay the human stories that unfolded under unimaginable pressure. Apollo 13 became a symbol of resilience, showcasing the power of human spirit against the backdrop of the vast, indifferent cosmos. In the annals of space exploration, Apollo 13 stands alongside stories such as the Fermi paradox and the enigma of dark matter. It remains a profound reminder that even as we reach for the stars, we must overcome the unknown challenges that accompany such audacious endeavors. Today, we'll explore how this mission turned disaster into a demonstration of human fortitude, setting a prelude to the unfolding drama that demanded unparalleled heroism from both astronauts and engineers alike. As we embark on this journey, let's uncover what made Apollo 13 not just a mission to the moon, but a defining moment in human spaceflight history. The Apollo 13 mission wasn't just another step on the ladder of lunar exploration. It was meant to deepen our understanding of the moon's geologic history, and by extension, the Earth and the solar system itself. Originally charted to land in the Fra Highlands, this mission was tasked with unraveling the mysteries buried in the ancient lunar surface. As an astrophysicist with a fascination for cosmic puzzles, I'm Dr. Mira Alden, and today we're delving into the ambitious goals that set Apollo 13 apart from its predecessors. Central to the mission was the plan to deploy a suite of scientific instruments to investigate seismic activity on the moon. These were to detect moonquakes and gauge the physical properties of the lunar surface, enhancing our understanding of its internal structure. Another key objective was to gather samples directly from the Fra region, providing geologists on Earth with data from this locale, potentially older than those from previous missions. Collecting these samples was akin to unlocking pages from a stone-bound history book, hoping to discover narratives about the moon's past that might mirror our planet's own formative tales. Apollo 13 also targeted cutting-edge technological goals. The mission sought to extend EVA durations, pushing the envelope of what was possible in terms of astronauts working in the harsh lunar environment. Alongside these ambitions rode the hope of advancing our capabilities with the lunar module itself, a critical component in NASA's broader dream of sustaining human presence beyond Earth. Each objective painted Apollo 13 not merely as another visit to the moon, but as a quest to lay the foundation for future explorations, endeavoring to transform lunar expeditions from fleeting visits into sustained engagements with our celestial neighbor. In the vast and unyielding theater of space, even the smallest malfunction can echo with catastrophic consequences. For Apollo 13, it started with a faint shudder, a whisper of trouble that rapidly grew into a crisis of life and death proportions. 2 days into their mission, as the astronauts voyaged toward the moon, the serenity of space was shattered by an unexpected explosion. At approximately 55 hours and 54 minutes into the flight, an oxygen tank in the service module ruptured, transforming a routine radio check into one of the most iconic transmissions in history. "Houston, we've had a problem." The damage was immediate and extensive. This sudden rupture wasn't just an isolated incident. It rippled through the spacecraft systems, compromising vital resources. Key electrical systems failed, cutting power significantly while depleting the crucial oxygen reserves, not just for breathing but for generating much-needed power. The astronauts, Jim Lovell, Jack Swigert, and Fred Hayes, suddenly found themselves in a fight to survive, far from the safety of our home planet. This was not the calculated, scientific endeavor they had embarked on. It was now about human endurance, resilience, and adaptability in one of the most inhospitable environments imaginable. The world watched in an anxious silence as NASA's team on the ground scrambled to assess the situation and formulate a response. In those tense moments, the dream of lunar exploration took a backseat to the more immediate aim, bringing Apollo 13's crew back to Earth safely. What followed was a testament to human ingenuity and the sheer will to overcome the unknown, compelling us all to wonder, not just about the stars above, but about the strength of human spirit in times of peril. In the heat of the Apollo 13 crisis, ingenuity became NASA's guiding star. The explosion of the oxygen tank had not only extinguished the dream of a lunar landing, but more pressingly, had crippled the spacecraft's ability to support life. Yet, amid the chaos, a symphony of teamwork and problem-solving unfolded both on board and on the ground. As the chilling reality set in, the astronauts Jim Lovell, Fred Hayes, and Jack Swigert found themselves in a crippled module, facing dwindling power and a compromised supply of water and oxygen. But what truly defined this moment was NASA's response. A network of brilliant minds came together, driven by a singular goal, bringing their crew back alive. From far below in Houston's mission control, Gene Kranz famously assured, "Failure is not an option." This mindset galvanized his team of engineers and experts into action. Under immense pressure, they worked tirelessly around the clock, using slide rules and quick thinking to devise immediate solutions. Back in the lunar module Aquarius, it was raw improvisation and old-fashioned grit. The lunar module, originally intended as a short-term vehicle for 2 astronauts, became a lifeboat for 3. The engineers on Earth crafted unorthodox solutions, like the now famous makeshift carbon dioxide filter fashioned from spare materials, plastic bags, cardboard, and duct tape. With it, they ensured breathable air on board, buying precious time. Amid these technical marvels, what truly stood out was the human spirit, adaptable, resourceful, and unyielding. As NASA's teams worked through each new complication with focused determination, it provided a masterclass in collaborative problem-solving, setting the stage for an extraordinary journey of survival. Amidst the extraordinary challenges of Apollo 13, the ingenuity that unfolded turned a potentially catastrophic disaster into an unparalleled testament to human resourcefulness. Picture this: 3 astronauts stranded in space, with failing systems and desperately limited resources, relying on Earth's brightest minds to guide them back home. Here, amid the tension and danger, arose a series of innovative solutions that would etch Apollo 13 into the annals of engineering legend. Faced with a failing command module, NASA had to improvise life support systems using what was on board. One critical problem, filtering toxic carbon dioxide, led to the now famous mailbox solution. Ground engineers devised a way to fit square carbon dioxide scrubbers from the command module into the round vents of the lunar module, fashioning makeshift air purifiers using materials like plastic bags, cardboard, and duct tape. This creative solution was not only pivotal for keeping the air breathable, but also highlighted the power of thinking outside the box when survival is on the line. Additionally, with power and water at a premium, the team meticulously planned the spacecraft's energy use, orchestrating a delicate balance to ensure enough resources for the return trip. Relying on rough computations and the astronauts' grit, they repurposed the lunar module as a temporary lifeboat, proving that necessity truly is the mother of invention. These moments of inspired problem-solving, where theoretical calculations in Houston paired with practical application in deep space, were instrumental in ensuring the astronauts' safety and return. It serves as a powerful reminder that even in the vacuum of space, where conditions are unpredictable and unforgiving, human creativity and collaboration shine as our most reliable tools for survival. Navigating the vacuum of space with limited resources and dwindling hope, the crew of Apollo 13 faced an extraordinary journey back to Earth. These astronauts were pushed to the limits of human endurance and ingenuity, embarking on a precarious voyage that would test the extent of human capability. As they drifted nearly 200,000 miles from home, a critical decision loomed before them, one that would ultimately save their lives. The strategic slingshot maneuver around the moon, an ingenious use of the moon's gravitational pull, was the key to aligning their spacecraft back on course. This maneuver was not just a testament to the precision of astronautics, but a stark reminder of our fragile dance within the gravitational boundaries of celestial bodies. Yet executing such a delicate maneuver under the circumstances was fraught with peril. The spacecraft systems were failing, power was being conserved to the bare minimum, and temperatures were plummeting. Communication with mission control faded at times, leaving the astronauts largely to their own instincts and training. They were piloting a crippled vessel, and every decision, every remaining resource had to be precisely utilized. Food and water were rationed, carbon dioxide levels were rising, and the crew was operating under extreme stress and fatigue. As Apollo 13 looped around the far side of the moon, out of contact with Earth, the sheer will of the astronauts and the relentless determination of those at NASA unfolded in real time. It was a defining moment that spoke volumes about human resolve against a backdrop of stark lunar desolation, the ultimate test of problem-solving, teamwork, and endurance amidst the silent vastness of space. The Apollo 13 mission, often dubbed a successful failure, left an indelible mark on NASA and space exploration. This crisis became a catalyst for profound change and introspection within the agency. In its wake, NASA faced the reality that human spaceflight, though awe-inspiring, was fraught with peril. Apollo 13 wasn't just about saving 3 astronauts, it was a testament to the fragility of life amidst the cosmos and the paramount importance of safety in a field where the margin for error was razor-thin. One major outcome was the re-evaluation and enhancement of safety protocols. NASA vastly overhauled its mission procedures, scrutinizing every aspect from spacecraft design to in-flight operations. The explosion of the oxygen tank led to rigorous testing improvements, ensuring that future missions would be even more resilient against technical failures. NASA's resolve to learn from its near catastrophe laid the groundwork for advancements that would echo through subsequent programs. Public perception of space exploration also shifted. While the Apollo 11 moon landing had been a triumph of exploration, Apollo 13 showcased the sheer unpredictability and danger of venturing into space. It highlighted not just mankind's reach for the stars, but also the resilience and courage required to overcome adversity. This duality captured the imagination of the world, reminding us of the noble gamble inherent in exploration. Yet perhaps their greatest legacy lay in the human spirit they exemplified. The Apollo 13 mission underscored a profound truth. When humanity pushes boundaries, it must be unflinchingly committed to learning from both its triumphs and its setbacks. This mission became a beacon of problem-solving and adaptability, qualities essential for facing the mysteries that space still holds. Apollo 13 was not just a mission, it was a testament to the resilience of the human spirit in the face of overwhelming odds. This harrowing journey transformed from a scientific expedition into a gripping rescue operation, providing a legacy that extends far beyond its original goals. It carved out a space in the annals of history as a lesson in tenacity and quick thinking, showcasing how teamwork and human ingenuity triumph, even amidst unprecedented challenges. As we look back on those tense days in April 1970, we're reminded that space exploration isn't merely about reaching new frontiers. It's about embracing the unpredictability of the universe with courage and innovation. The story of Apollo 13 underscores a fundamental truth. Advancing into the cosmos also means confronting unforeseen obstacles and daring to solve them. The legacy of Apollo 13 extends beyond its immediate impact. It pushed NASA to rethink its safety protocols, ensuring future missions would carry forward with enhanced robustness and foresight. This relentless pursuit of improvement and knowledge reflects our species' inherent drive to explore the unknown, much like our discussions in previous episodes about the Fermi paradox and the invisible forces shaping our galaxy. Apollo 13 remains more than a historical event. It's a beacon of what's possible when intellect and imagination are called upon in extreme conditions. In the grand narrative of space exploration, it reminds us that while the path to the stars may be fraught with danger, each setback brings invaluable insights. As explorers of both the known and the mysterious, we carry forward the lessons of Apollo 13 as we continue to venture into the vast unknown, inspired by the courage to uncover what lies beyond our earthly horizon.